Now, today specifically, I want to talk a little bit about tabular data. And this is part of our course, Data Science 1, which is coming up in January. And this is a sort of, it's not one particular lecture from it. It's a mixture of a little bit of lectures from it, as well as a sort of like idea on how to do a whole bunch of analysis for tabular data. So let me go to the slides and we can start from there. Okay, so tabular data, what's tabular data? It's basically a table, like the stupid little diagram you can see in the upper left corner. But I want to use tabular data, as it were, as a ringer, if you like, for multiple kinds of data. But tabular data is really the kind of data you find mostly just about everywhere, right? It's just like spreadsheets, it's tables, it's in all the Excel spreadsheets in businesses all across the world. And so it's probably the most important kind of data to analyze. It is not the only kind of data you will encounter, right? You'll encounter images, you'll encounter words, you'll encounter networks, your social media networks, all of these kind of things. And there are different ways you want to analyze these different kinds of data. But tabular data is definitely the most frequent. You'll find it everywhere. And so it's kind of important to have a good handle on how to deal with it. So you might have seen some version of this Venn diagram by Drew Conway. It's the sort of like the data science Venn diagram, and it's a sort of intersection between three different sets of skills. So one is statistics and machine learning. One is domain science. So, for example, I was a astrophysicist. So that's where my expertise came in from. And then, from computer science, your ability to program or your hacking skills. And it's really, you need to be able to do all of these three things to do data science well. Now, when I use the word data science here, I mean it in a very sort of general sense. I don't mean it as data analytics or business intelligence or any one of these things, though these are important components of data science. I've been sort of told like that this word has a lot of meanings for a lot of people. So I just want to make that meaning that I'm using it in quite clear, that I mean it as, a combination of all these three different sort of skills. And I'll continue using data science using this terminology for the rest of this talk. And so what is data science then, right? It has tons of different things in it. Some of which are more human, storytelling. Your data's telling you a story and you're trying to figure it out. Some of it is decision making. Should I use this model to make a decision about where I should buy my ads or whether I should not? It's got visualization, it's got business intelligence stuff, statistics, data management, which we'll talk a little bit about today, data mining, machine learning, everything, all of these things put together. So there's a process that you want to sort of follow. And this is really, I think, at some level, probably the most important slide over here. So briefly, what you're doing is you're asking an interesting question. Why are my customers leaving me as a company, say, for example? Or why is, why is the universe expanding? And why is the acceleration of the universe, of the expanding universe high? So what's going on? So that's sort of like the question you're asking. Now you need to get data. So you need to get data on your customers, or you need to get data on how the universe is expanding and stuff like that. Now, after you get the data, you need to munch this data in some form. You need to get data from different sources. You need to combine this data. And that's where a lot about where this talk is today. You need to explore this data. You need to visualize this data. You need to look at all the various columns in this data, all the various features in this data, and ask what it's telling you. You want to model this data as well. And when you're modeling this data, this is where you use your machine learning models. This is where you bring in the deep learning. This is where you do all of this stuff. But once you're done modeling the data, you're not done. You have to validate the model. You have to see if the model makes sense. There's a funny kind of story from a Kaggle competition that Jeremy Howard, who runs Fast.ai, talks about in modeling the data. When he sort of he had a Kaggle competition on, what variable was the most predictive, if you like, whether you got a grant or not from a government agency in the US, right? So there's all this kind of data about the various proposals people make to get grants. And you have to predict whether you got a grant or whether you did not get a grant. And he found that when he did this, that the variable most associated with a prediction of getting a grant was a little administrative variable that had been put in out there. And he kind of finally realized that an administrative variable was actually put into the data after the grant was granted. So in other words, the entire model was completely bogus uh, because it was talking about stuff that the government had put into those columns and forgot to clean before giving the data to Kaggle. So, you have to be very kind of, you can't sort of like go off the blinker and not use your common sense. So you have to validate the model. And then finally, you've got to communicate and visualize the results. You can come up with all the best results in the world, but if you can't explain them to your boss, you may not have a job the next day. So these are all important aspects of the data science process. Today, we're going to focus mostly on the second and third one, get the data and explore the data. But as we'll see, the techniques we talk about today are applicable in all these different steps. So to talk about Univ.AI a little bit and how it relates to these kind of steps, we're sort of a deep learning shop in the sense that we'll teach you a lot of AI, a lot of machine learning. All our data science courses have a lot of machine learning in them. And we offer, if you like, in terms of like the main quote unquote paid courses, a whole bunch of courses. There's over here, you can see 7. There's machine learning and data science 1, machine learning and data science 2, which is the bread and butter of what I'm going to talk about today. But there's also AI 1, AI 2, AI 3, AI 4, and a capstone project, which embeds you inside a company or a research lab. Now, all the blue things in this diagram, all these sort of like light blue things, these are the courses. And the pink things are the programs which, encompass these courses. And there are 3 certifications that come out of this. There's a Master of Deep Learning, which does all the AI courses, AI 1 through 4, and then does the capstone course on top of it. There is the Master of Machine Learning, Data Science, and AI, which is everything. And then there is Fast ML Data Science and AI, which just does the initial part of the AI courses and the initial part of the data science courses. This is roughly comparable to what we used to teach in Harvard's CS 109 course. And so this already the Fast ML, DS, and AI will position you for a high-paying job. It's kind of quite funny because I have so many students of mine who, after doing CS 109, went out into industry and got jobs and landed up getting way more money than I ever made at Harvard. So that's a good thing, I suppose. Okay. So today we'll focus on tabular data, and I'll try and give you a sort of flavor of how we deal with it. And along with a flavor of how we deal with it, I'll be sharing a notebook on Colab with you. And this notebook has a lot of rich stuff which you can take away from this class, even if you don't take away anything else. If you know how to use pandas in Python, it will teach you SQL. If you know how to use SQL because you're coming in from a programming background, it'll teach you how to use pandas. And if you don't know either, it'll teach you both. So it's actually a kind of nicely crafted notebook, which, if you have a little bit of patience, it will give you a lot back. So I hope you enjoy it. So now, the basic skill that you need to be able to do anything of this is Python. And we're running a free Python course next weekend. You can go find it on our website. It's the Python Preparator course. And we have 2 preparatory courses, the Python Preparator and the ML Preparator. For those of you who have already taken our AI 1 and 2 course, you don't need to take these. But if you're coming in to do DS1 and DS2 completely new, you want to take these preparatory courses because it will, kind of make sure that you're at a level where the courses, the courses don't fly a little bit too high above you. So in any case, you should learn Python. It's a really good skill to have. And, as the XKCD cartoon says, you can fly with it. Okay, so moving a little bit further, what's tabular data? We talked about this a little bit, but it's basically spreadsheets, Excel sheets. And as you've probably done this before when you've done stuff in Excel or in Google Sheets or anything, you can have more than one sheet, and one sheet can refer to the other. So for example, here I have two sheets. I have items and customers. And in the customers table over here, I have a column which calls itself item index. And that item index points to the item in the items table. So item index 2, for example, in the customers table, points to the index 2, which is medium, craft, and a price of 12 in the items table over there. Now, some of these values, as often happens in Excel spreadsheets, could be missing. And you might have even put multiple comma separated things in a cell, right, in Excel. So it can be really kind of quite dirty. And dirty data is hard for computers to deal with, so you need to clean it. So in this get data part, which we're going to mostly talk about, there's a lot of emphasis on getting the data from various sources, from various databases, and all of these kinds of things, and then cleaning the data. And this is the stuff we actually do in our course, in the DS1 course, as part 1. And then in part 2, we move on to combining this data together, exploring the data and visualizing this data. And then in the rest of DS1 and in most of DS2, we go into modeling data, interrogating this model to figure out whether if it's making any sense, and then making decisions based on your modeling. So this is the flow that our courses do, and this is basically the data science flow that you will want to do every time you are you encounter a new project that you want to do. So tabular data, we just sort of like introduce these two items and customers screens. And tabular data tends to be in 3 different types. One is quantitative. You're familiar with this kind of stuff. So it's like the price over here. In fact, I think I have a slide for it. Quantitative data tends to be things like price. Okay, it's so many dollars, so many cents, or so many rupees, so many pesa, right? It's a floating point number. It's a real number. Then there's another kind of data, which you'll find a lot of, which is called nominal or categorical. And that's basically something of one type or the other. So here we're talking about items, and item 0 is of type toy, item 1 is of type book, item 2 is of type craft, and item 3 is of type craft. So now toy, book, and craft, there's nothing like saying toy is greater than book, is greater than craft, or anything of that sort. They're just different categories of things. So this kind of data is called categorical data. There's a third kind of data, which you'll find quite often, and that is that's what's called ordinal. And ordinal does actually have a ordering. So for example, if you look at the quality column over here, you have high, you have medium, you have low. Now, clearly, in some sense, high is greater than medium is greater than low. But how much is high greater than medium, or how much is medium greater than low, is not necessarily quantifiable, right? As 20, 10, 0, or something of that sort. So there is an ordering, but the ordering is very kind of weak, right? It's only saying that something is better than something else. And that's called ordinal data. And when you are dealing with data in general and tabular data specifically, you want to handle all of these 3. The fourth really important piece of data, which you can see in this customers table over here, is something called a foreign key. And a foreign key is basically an index into another sheet of your data. So you can see there's an item index over here, which is talking about the item in the other sheet. And this paradigm of modeling, you've probably seen it a million times in spreadsheets. If you worked with databases, you know that this is the foreign key idea in databases. If you worked with pandas, which is the tabular model in Python, then you have seen this there as well. But if you haven't, it's kind of like fairly obvious an idea, right, that you would have come up with eventually if you wanted to refer from one sheet to the other. So that's what it is. Okay, so this might be the second most important slide, which you should take with you. This is a rubric for data analysis pre-modeling, and this is what we kind of want to do with our data over here. So actually, I think I need to change this a little bit more. Here we go. Yeah. So rubric for the for data pre-modeling. What we typically want to do is we want to build one table from the data. So you want to take all the sheets and you want to put them together. So ideally, you want to put all the data in this object. In database parlance, this is sometimes called denormalization. And this is kind of important because it actually makes you be able to run the model on just one table. And that's how most algorithms expect your data to be. Now, so to do this, you have to somehow or the other combine these sheets. And this notion is called joining. So we'll learn about that a little bit later. Then there's a second thing. You need to clean the table. And this can have lots of different things. And this is what we were talking about in the Q&A. It can be terribly complicated, and you will spend a good amount of your time on this part. So what you want to do is that each row should describe a single object or a single observation or a single data point. Each column should describe a property of that, the price of that or the quality of that item. Whenever it's appropriate, the column should be numeric, right? So like things like prices and stuff like that. The columns should contain atomic properties that cannot be further decomposed. So you don't want things as much as possible like lists and so on and so forth in any one cell of your spreadsheet or in any one cell of a particular column. So you don't want multiple prices in one place. If you're going to have to model multiple prices because you're offering different kinds of discounts to different people, you should model those as separate rows. That's sort of the idea behind that. We'll see some of this as we go further. Then you want to explore global properties. So you want to take every column and you want to see what its properties are like. Okay, what are all the prices in my system, right? I mean, are most of my products low priced? Are most of my products high priced? What is the mean price of all of these things? What is the maximum price? What's the minimum price? So these are all kinds of like data summarization things. The next thing you want to do is to explore group properties. So the idea behind group properties is, well, let's look at all the toys. What's the mean price of all the toys? Which customers are buying toys? All of these kind of questions, right? So you want to get these kind of groups and understand what's happening in a group and compare what's happening in a group to the aggregate. Are toys on the whole cheaper than all the items in my shop? Are they more expensive? Are people buying more toys? Maybe I should not sell other stuff. All of these kind of questions. And then finally, you want to explore both these global and group properties for combinations of this data, different kinds of features that you want to combine together and understand what is going on. So this is this kind of rubric, and no matter what model you do, that more precisely, no matter what tabular model you do, you're going to have to do these things before you get to the modeling stage. So again, probably a good takeaway from today. Okay. So in pandas, which is a library in Python, there's the in-memory table structure. And this in-memory table structure is called a data frame. It's a very fast library, and it's used extensively in data science, deep learning, machine learning, everywhere. And basically, it just takes a spreadsheet and composes it of a set of columns. That's all it does. That's the basic idea. And we'll see in code a little bit of how to do it. So at this point, if you're familiar with Python, if you're familiar with pandas, this stuff will be easy to you. If you're not, don't worry. Just follow along and see what the code is doing. You can learn this later, right? But I wanted this talk to at least be somewhat practical and somewhat so that you can go with it and do something useful once we're done. So we're going to look at two tables. One is a table of candidates, and this is for the 2008 election in the US. And then one is a bunch of people who contributed money to these candidates. And so that's what we're going to go look at. And there's a notebook. And what I'm going to do is I'm going to share on the chat. So I pasted it in the Zoom chat. You can just click on this link. If you don't have a Google account, just follow along what we're doing. If you have a Google account and you feel comfortable with running Jupyter Notebooks, feel free to go ahead and run this. Running Jupyter Notebooks is really quite simple. All you have to do is, you see right now, the focus is in this Pandas SQL and grammar of data cell. You just have to hit Shift and Enter. So go there, and then just hit Shift and Enter. I'm putting my cursor in here and hitting Shift and Enter. So can I see the chat window here? Okay. So click inside here, click the chat. Are you guys able to see my chat window at this point?
Yes, it's visible to us.
Okay, super. So I click in there. I go into Colab, and what you missed is that it actually asked me to log in. And we'll ask you to log in too if you're trying to run this. Kill the chat window. And while this thing opens up, now the moment I try to actually run this, it's going to complain at me. And I'm running it by hitting Shift and Enter. Okay, I'm just going to click on Run anyway. So that's one way you can do this. The other way you can do this, and this is probably kind of better for you, is to make a copy of this. So you can do save a copy in your drive over here, and then run it like that. So it's your choice how you want to do this. So I could save a copy in submissions drive, open it in a new tab. Now it's going to make a copy for me. And now I can run it. Okay, so it's going to take some time to run. So that first cell will run. Once that cell finishes running, that thing that goes around like that will vanish. And right now I'm loading everything, and once it finishes, it kind of puts this like 1 in there. And I can keep hitting Shift Enter to go from one cell to the other. So right now what I will do is I will actually stop this share, and I will share my screen, but only share the Safari, so it's actually visible to you in a little bit better fidelity. Okay. So just keep hitting Shift Enter if you want to run this, or just watch me do it. Okay, it's up to you. I'll leave it to you. Again, I'm not going to run all the cells because there's a lot of exciting stuff in this notebook. I thought I should provide it to you, so I did. But I'm just going to run the cells that are kind of important to what we're talking about today. So here, I'm just getting the data down onto a Google Colab. Don't worry if you don't understand this. It's a Unix command. It just downloads the data. Colab provides you with a Unix virtual machine. And these files are in CSV format with a pipe separator. So I'm going to use pandas PD is how I'm calling on pandas over here. And you see that over here by Python's import statement, where I'm doing import pandas as PD. So it allows me to say PD every time I want to say pandas, because I'm lazy to type out pandas all the time. And once it does that, it reads that table and it sort of like displays it to me like a spreadsheet. So that's what's happening over here. So you see the structure of this data. It has an ID of the candidate. It has the first name of the candidate, the last name of the candidate. You can see that Joe tried to run for president back then. If you remember, the US system has this system of primaries in which everybody from the same party, they fight against each other to become the presidential candidate. So you'll see Joseph Biden, Hillary Clinton. Somewhere you should see Barack Obama over there. All three of which are Democratic candidates. That's the party field over here. You'll see the middle name field. They actually haven't put in the middle names of a lot of these candidates, and that's why you see a NaN, which stands for not a number. That's missing data over here. And you can choose how you want to deal with this missing data. And then you can also read the other file we have over here, which is the contributors with candidate ID, which is this kind of customers, items paradigm we were talking about, right? Where I put in the candidate ID out there to refer to the other sheet, right? That's what I'm doing over there. This does not have any IDs in this particular column, so we'll have to get rid of this column. That's sort of like almost the immediate kind of cleaning we might have to do with the data. It gives you the last name and the first name of the person who made the contributions. Sometimes it might have a middle name, sometimes it might not. Has a street too in case your address is really long, has a city, has a state, has a zip code, which is like the PIN codes in India, has an amount of money you contributed, and the date you made that contribution over there. So let's just clean this up a little bit. Okay, so I just got rid of the ID column. You can see I just deleted it over there. Delete DFC WCI of ID. In case you're wondering what on earth these names, variable names that I came up with are, DF cand is for DF candidates, data frame candidates, and this is for data frame candidates with candidate ID. Yeah, it's not particularly imaginative naming, but that's what it is. Okay, so this is a little kind of introduction to pandas. And you'll see, for example, one of the things you might want to do is to make sure that these names actually make sense. By the way, you don't have to hit Shift Enter. You can also hit this little arrow doodad and it will run it for you. And it's telling you that the IDs are integers, which is kind of good. So this is the candidates table. Look at this candidates table over here, a little bit higher. IDs are integers. And whenever pandas tells you object, it actually means it's a string. So something like Joseph, Biden, middle name, and party will all be strings over here. And you see that out here. Object, 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 object. I can do something similar for the candidate table. And you see there's a little bit more exciting stuff happening here. It thinks that the pin codes are actually integers, which they are to some degree, but they're not really, I would say, integers, but that's what it thinks. That's okay, we can deal with them as integers. It thinks the amount that they contributed is a float, which is kind of good. Sometimes you'll have amounts written in other words. It might say like $500 in it, and you'll have to convert it. Data can be weird, but luckily over here, all the data is reasonably clean. The date is a particular date kind of object. It's a string. Many times you'll want to actually convert this into a Python data object and do interesting things with it, because then if you convert it into a Python data object, you can think about things as a time series. And you can ask questions like, oh, this person, how many contributions did they make? When did they make it? With what difference in time did they make it? Stuff like that. And then you notice that this candidate ID is an N64 because it points to the other table. Why 64? Because my machine is a 64-bit machine, as is probably yours. Okay. All this is all very exciting. Actually, no, it's kind of boring. But what you really want to do is to be able to query these data frames in some fashion or the other, right? So here's how you do it. If you just want a column, we'll just ask for the column with this kind of dictionary syntax, where df cand of first name. So it's asking you, what's the column, which is called first name, and it gives you this. Want more than one column? Put them in double brackets, and it will actually give you a subtable, a subsheet, if you like, or a subdata frame with the things inside it. Okay, so that's to get individual columns and to get sets of columns. But if you want to do something exciting, like tell me everybody who's a high roller and has contributed a lot of money to these candidates, so more than $2,000, okay, we'll just ask that condition over here. It's saying, go into this table, find the column amount, ask if the column amount is greater than 2,000. So this statement inside, and I can show you what it looks like by adding a code cell by going to the plus code over here. So this statement inside of here basically does a comparison for you. And it tells you whether the amount is greater than 2,000 or not. If it is greater than 2,000, it'll return true. Otherwise, it'll return false. And then when you put it inside the df CWCI, that true or false basically picks out a row. So what it has done over here, it has picked out the rows in which this condition came to true. And so you see that, for example, RD Altes of 8600 Moody Road, somewhere in Arkansas, made a contribution of 2,300 over there. And the highest contribution over here is Linda Buckle from Park City, Utah, who made a $4,600 contribution. And it made it to candidate ID 20, which is not a very useful way of looking at it, but we're going to learn how we can actually combine these two tables together to see this in some useful fashion. Okay, so let me stop sharing this screen here. And I believe, let me check, but I believe it may be time for questions. Yes, it is time for questions. So, so what did I do in this segment? What I did in this segment was to talk about the basic sort of like ideas of how do you load one of these spreadsheets or one of these tables into memory, and how do you do the basic sort of like querying of it. Just to give you an idea of what the structure of these tables are. So this is sort of like building on the question that was asked. What is the kind of data storage you need for your data? Your data may be huge. It might be, pandas kind of assumes that the data is in memory. But what if it doesn't fit into memory? Maybe you need to get it from disk. And for example, there's a extension to pandas called Dask, which lets you get this stuff from disk. Or you use a database, because databases work very well in having all the data on disk and only getting some of it into memory at any given moment. So you start with memory, and it's like, my data is not fitting into memory. Okay, so let me get it from disk. But what happens if it still does not fit into disk? Maybe I have to get it from a cluster, 2, 3, or 4 different machines. And maybe if I do it on 3 or 4 different machines, I can make everything faster by fitting it into memory on those 3 or 4 different machines. But maybe my data is too big. It needs to be on disk on all of these machines. So that's what's happening with the Tufts Healthcare problem I told you. The data is so big that it needs to be obtained from database pieces, which are on multiple machines, and Cloudera helps you do that. But what if I need to use just parts of the data? Okay, maybe I can then actually do things in parallel from a cluster. What if my data is so large that it makes no sense to move the data? Maybe I actually need to move my programs to the machines where the data are. So there's all these different kind of modalities in which you may want to actually use data. And there are different tools which have been created for this. So for in-memory, there's pandas. For across a few machines, there's Dask. For a really industrial scale solution, there's something like Spark, which will actually do the kind of analysis split up on different ways in an immutable kind of fashion. So there's all these different things. But so at this point, you're like, oh no, this is bad, right? The beauty is that we are going to learn something called a grammar of data, which will actually help us not have to deal with this. But very quickly, what's a relational database? It basically says seek 20 bytes. It doesn't say get 20 bytes from disk and pick it up from there. The next row is going to be 50 bytes hence. It basically says select data from a set. I don't care where it is. I don't care even if it's on this machine. Get it for me. That's the kind of idea of a relational database. But the model of a relational database is this pandas model, is this spreadsheet model. It's just the same model that we've been talking about. It's a collection of tables related to each other through some common data value called a key. Rows represent attributes of something or different observations. Everything in a column is the values of one attribute. Every cell is expected to be atomic. You're not throwing lists into cells, just like you're not wanting to throw lists into cells of an Excel spreadsheet. And tables are related to each other if they have columns called keys, which represent the same values. This was the customer ID we were talking about, or the candidate ID we were talking about in the contributors table. And so SQL, it's this lingua franca of relational databases and a lot of other systems. And we'll get to the notebook and talk about SQL a little bit, but I'm going to actually skip forward a little bit and talk about the grammar of data in the interests of time. One thing you will notice is that every system has the same kind of functionality. There are core data manipulation systems, which are universal, core data manipulation commands, which are universal across systems. And by identifying them, we know what functionality to search for when we encounter a new system. And it was first formalized by Hadley Wickham, actually in R, in a package called dplyr. And you can see the link if you'd like to read a little bit more about this. Okay. So we'll come to these verbs, but let's actually go back to the notebook for a second and see what SQL looks like. So for those of you who have encountered SQL before, this might be super boring. Please bear with me. For those of you who haven't, I think you'll have some fun. And you'll see how some of these things, at least the beginning things, are very, very similar to what we just saw in pandas. So SQL. Now, SQL is what's called strongly typed. There are actual types. So you need to actually create the tables in a database before you can put data into them. So I'm going to create a table candidates, and I'm going to create a table contributors. And they're having all the things, all the columns that we had in our data frame. How do I know What kind of stuff, what kind of types to give them? Well, I know that the IDs need to be integers. Everything else, I'm just modeling the way I had my D types. You saw the D types, remember, up here. These thingies here. I'm just going to model it in exactly the same way. So you see I have, except that I think I made the amount an integer as well, because it turns out that you can't do these cent-based things. So I made that an integer as well. So that's the only difference. So I'll run the cell. And the database we'll end up using is a database called SQLite. Why am I using SQLite? It comes with Python. Actually, SQLite is such a good, useful little database. It's an on-disk database rather than a large one like SQL Server or Oracle or Postgres or one of these. It's actually built into just about everything. Safari browser has SQLite in it. Chrome browser has SQLite in it. Firefox has SQLite in it. Your Android phone has SQLite in it. Your iPhone has SQLite in it. Just about everything of any use has this built in as a little database into it. So, and it's built into Python as well. So it's actually worth using. And the way you're going to use it in Python is you're going to use something called the DB API too. It's a standard API. It works across any SQL database. And what do you have to do? 2 or 3 things. You have to connect to the database. Since SQLite databases are in files, you just have to connect to the file over here. Once you get the file, you execute a script. Once you execute a script, you commit. And this is the idea of a transaction inside a database. And the idea of a transaction over here is that all of these things either happen, or if something makes one of them not happen, none of them happens. And this makes sure that your database is in a sane state, right? So if you imagine, if you're Amazon and I buy something from you, and the table of the inventory table loses the let's say the roller skates I bought from you, but the pricing table does not, and that would be kind of bad because the inventory would be off with the money table. That's not what you want. So you want all of those things to happen together, and that's why you need to do these commits. And so basically what I'm doing is I'm putting this connect into a function. I'm calling that function here. I'm executing the script and I'm doing a commit. So this initialization of the database initializes everything in the database for you. So we just run these function definitions and then actually initialize the database. So I'm going to create a database called candidates contributors cancont.db. And if I do a listing of files in my current folder, you'll see I have this cancont.db file, which is what I'm connecting to. Turns out I can actually populate these using pandas because my types kind of match, and where they don't match, there's a conversion which is done. So for example, my amount is a float 64, but in my database, I made it an integer, so it'll actually just convert the float to an int. And so I will just very quickly put stuff in the database, and now I'll do a query. And in SQL, if you want to make a query, it's select star from candidates. The corresponding thing, remember, if you remember in pandas, was df canned. That's it. Get everything from it. I'm just going to run df canned. Boom. It's going to give me all these. That's exactly what I'm doing over here by saying the select star. So let me run this. And then I can do the fetch all, which is going to fetch everything I ran. And I can remove it as well, delete from candidates. And notice I have a commit at the end to make sure it's done. And then if I don't fetch all, there's nothing. So now you might have this feeling that I cheated you because I actually converted Python a data frame to a SQL table. You're absolutely right. I did cheat you. So let me not do that. This is how I add things into SQL. It basically says insert into the candidates table ID, first name, last name, middle name, party, And these values, question mark, question mark, question mark, question mark, question mark, are just interpolated. I'm not going to go into the code in any amount of detail right now, right? Because that's not my point over here. I just want to show you that the syntax is actually very simple. And you can run it. And then you run a commit at the end. Notice that for each of these lines, you're creating a cursor, and then you're executing this command. Okay. So I insert, 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 insert. And in the course, we'll go into what each one of these things means into a great amount of more detail. I'm also going to create a little function called make query, which does all of these things and fetches them so that I don't have to write the same code all the time. And here I'm doing select star from candidates, and it gets me all the candidates. And I think you might actually agree that this is not the nicest kind of look. So I'm going to do this removal once more. I'll do this insertion once more. And then I'm just going to write a little function for us, which will display it in a somewhat nice fashion. And I'll actually just go ahead. No, maybe I think I'll actually wait to go ahead with that. Okay. So you see that these are some of the kind of things you can do. You can insert, you can select, corresponding to some of the things we kind of did with pandas earlier. Okay. So again, let me take a quick break over here and see if there are any questions. So the reason I take a lot of breaks is because the general way we try and do it in these courses, we go only for like 10 to 20 minute sessions, somewhere between 10 minutes and 20 minutes. Then we actually pepper you with about 2 or 3 exercises and do a little bit of question answering, and then we move forward. We don't let you ask questions at any moment in the course, because that could be somewhat disruptive, and we would probably just land up answering questions rather than actually doing any of the lecture, which is also fun, but we have office hours for that as well. And then we kind of move forward. So it's always at any given point, expect to be asked questions, which are supposed to test your understanding of that particular mini section. And then expect to be able to ask questions yourself as well. So in this little mini part, what I did is I showed you what SQL kind of vaguely kind of tends to look like, and pointed out to you that there is a database which is built into Python and built into every operating system and every browser and almost every piece of software called SQLite, which you can use no matter what operating system you're on, Windows, Mac. I'm on Mac, Linux, whatever you use, which you can do stuff with. And so I'm going to use that as a demonstration, for today. So let me see if there are any questions, and then we'll move on to the last thing I really want to talk about today, which is this kind of grammar of data, which is this kind of notion that once you know any one of these systems, you know all of these systems. So you just need to learn one, whether it's pandas or whether it's SQL, your choice. The way I structured today's stuff is to show you both the pandas and SQL things next to each other, so that you can do stuff with it. So then let me go back to my slides, right? And when I go back to my slides, let me share my screen again. Let's see, here it is. Okay. So I think we just went past this question. And this, I think, is one of the most beautiful things, this kind of grammar of data thing, right? Core data manipulation commands, they're universal across systems, and by identifying them, we know what functionality to search for when we encounter a new system. Okay, and it was first formalized by Hadley, Wickham, and Depplier. So actually, even before looking at it, let me ask you. So I've given you these bunch of tables. What are the kind of things you might want to do with the table? Let's look at a table to make this concrete in our head, right? Here, these are our tables. So at this point, just feel free, unmute yourself, shout out something you might want to do with the table, and then mute yourself back again.
Separate important columns from the trivial ones.
Separate important columns from trivial ones. Yeah, what else?
Select who is contributing the most.
Select who's contributing the most. Yeah. So in that sense, you would say that that's a kind of query, right? That you want to be able to deal with. Yeah, go ahead.
Search for
target
outliers.
Look for outliers. Very good. So let me see if I can write some of this.
Jatin Sharma says separate party affiliations.
Yeah. So all of these are kind of selects, right? Check for party of so select something. Select rows. Okay. So let's try and formalize that. Select rows based on some columns, particular values. Would you say that's a good description?
Yes.
Yeah. Okay.
Which party?
Somebody else said remove unimportant columns. Yeah. Good. Go on.
Which party collected maximum amount?
Okay. So you want to calculate statistics like maximum, minimum, maybe mean, median, right? All of that kind of stuff. And this you might want to do on a per column basis. And then you may want to do some further selection based on that, right?
Right.
Okay, go ahead. What else?
Like which party has most funds?
Okay, but again, that's something like selecting. Okay, no, you're actually saying, okay, which party has more funds? So again, that's a global statistic, right? So you would probably combine that by looking at the funds table and then grouping it by party, right? So what you're saying is that, actually, I think you're making a good point over here. You're saying group by a subgroup, like party, and calculate some statistic, right? So in this case, you're trying to calculate a sum, right?
Yeah.
Okay, what else?
Yes, sir.
In the chat, we have Aliza Shamsi who's saying assign distinct integer values to qualitative data since it's easier to work on.
Yeah, assign distinct integer values.
And
so in other words, assign values to a new column, right? Or insert a new column.
We also have
based on some computation.
Shikhar Jain, who says number of voters from different cities and candidates from which city contributed the most.
Right. So yeah, again, this would I think be based on some combination of grouping by some subgroup and then selecting, right? And possibly doing some statistic. Yeah, these are all very good.
Group candidates from the same city, from Bhavya Soni, I think. Is that
similar idea?
Is that complete, Bhavya? It says group candidates from same city with, and there's nothing that follows. All right.
Okay, so these are some of the things you can do, right? So this is really good. Now you'll see, I'm going to go to the next slide. And you'll see.
Rahul, Vinayak has a question if you want to take it.
Yes, go ahead while I struggle with my screen over here.
All right. So Vinayak asks, if we give integer values to qualitative data, won't a new relation be formed?
If we give integer values to qualitative data, won't a new relation be formed? Absolutely. Absolutely, and yeah, no doubt. So going back to that slide over there. So these ideas that you guys said, and which I tried to sort of like abstract out, right? These form a set of core data manipulation commands, which are universal across systems. And here's an example of it. So I've actually put in dplyr and R if you're an R person. And I've tried to like classify the the verbs over here on the left and put in the pandas and SQL equivalents. So the one on the left we talked about, right? That's query and selection. Then some things we didn't talk about is we might want to sort, right? By saying who are the highest. I think actually somebody said that. Who are the largest contributors? So you may want to sort your table by the largest contributors, right? You may want to select particular columns, right? Just one column. So that's basically this idea of a projection. You might want to select distinct, right? Because you may want to find unique stuff. You may want to drop duplicate data points in terms of cleaning. Then there's this notion of assign, where you want to assign a new column which is based on these integer values corresponding to something which is categorical. Then you might want to aggregate. This is what people were talking about, doing sums and doing maximums and means and describe. And you can see that in pandas and in SQL, all of these have kind of equivalences, and some places they may not be. Like pandas has a very nice thing called describe, which will give you a lot of statistics which SQL doesn't have. But you can construct up in SQL by combining multiple different SQL commands. Then there is sampling, doing random sampling. There is a group aggregation. This is doing group by party, for example, and then calculate something. And then there is deletion, right? You may want to delete tables which you don't care about and stuff like that. So there are all these different kinds of modalities in which you might want to work on the system. Okay. So in the interest of time, because I'd like to finish in the next 5 minutes or so, let me actually also talk about a different kind of grammar. So these are everything which you're doing on one single table. This is one spreadsheet stuff. But remember, we talked about actually combining these kind of spreadsheets together. So you may want to talk about these kind of two-table verbs, right? And these two-table verbs are stuff where you actually want to join. And again, there's a classification for this, which is due to dplyr, mutating joins, filtering joins, and set operations. And these are not covered today or in our notebook, but the notebook does cover mutating joins. And actually, this may be a good point then to flip to the notebook and see some examples of these. And I'm only going to do like 2 or 3 examples. There's lots of stuff in the notebook, and you have access to it. So feel free to read it at your own leisure. Let me get my Safari up, and then let me go with this in full screen so you can actually see the full screen. Okay. Is this readable?
Yes.
Yeah. Okay. So the grammar of data. So I've again reproduced that table for you over here. But you've already seen how to do these queries. And here I just give you an example of actually combining these queries together. I'm looking for the state of Virginia and people who've contributed less than 400 in Virginia. I can run this query on my pandas table. I can also do it in this particular fashion. These are just different fashions. You'll find this notebook will actually give you a lot of information about how to do these various kind of queries. These next 2 cells, don't pay too much attention to them. They're just a way of making a data frame from the result of the SQL query, because I wanted it to kind of look nice when we see it. So it's exactly the same query we were doing in pandas in SQL. It's the same idea. We're doing a selection from our table where we have a particular state and an amount is less than 400, right? So and you can see, boom, we have this nice little table over there. There are all kinds of variants on it, which I'm not going to talk about, but both in SQL and in pandas, you can ask for, oh, what happens if there is no state given? And look, there is at least a Travis born in the city of Brass Chat, and we have no clue what state it's from. The zip is kind of weird too. It's like a 4-digit zip. And zips in the US are 5 digits. So something weird is going on with this Brass Chat dude. And we have no clue what's going on over there. We can do exactly the same thing in pandas. We can ask a question, select star from contributors where state is not null, which is going to have a lot of almost everything else. And you can do exactly the same thing in pandas too. So you'll see that in both pandas and in databases, you'll have the same set of things. Here's a slightly different one. It says select star from contributors where state is in a particular list of states. Here, Virginia and Washington. And the same thing in pandas. Select star from contributors. Oh, I don't think I've actually done that in. Oh, no, here it is. Where state in VA and WA. And in pandas, it is dfcwci.state, the state column, is in a list which has Virginia and Washington in it. It almost reads like English, right? That's kind of the idea here, that these verbs all read by English. And if you know these verbs in any one of these things, you know it in the other. I would say that you should at least know it in pandas and SQL, because you'll be, no matter what job you go to, you'll be expected to know SQL. And if you're in any kind of data science job, you'll be expected to know, if you're in an R shop, you'll be expected to know dplyr. If you're in a Python shop, you'll be expected to know pandas. In both places, you'll be expected to know SQL. So super useful. And SQL is simple. Select star from contributors where amount is between 10 and 50. So now you can do a kind of range query. Same range query can be done in pandas as well, and so on and so forth, right? And then you can sort and do all of those kind of things, blah, 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 blah. You can select just particular columns. You can select distinct, dropping duplicates. I'll let you take a look at this at your own leisure, essentially. Here's assign. Assign is actually kind of super interesting, right? Because I want to be able to create a new column, which has been made in some way from a computation of two given columns. And here you'll see that I have assigned a name which combines the last name and the first name. And I can do that in pandas relatively simply by just creating a new column like this. There's some other ways to do it, which I talk about over here. This is a fairly comprehensive notebook. It'll teach you a lot of pandas as well. But I'm not going to be able to go through all of it. But let's go and see how this is done in SQL. It's a little bit more complicated in SQL because of the way relational databases came about. I have to alter the table, contributors, and add a column called name. And then I'm going to select these things from contributors, select ID, last name, and first name from contributors. So I selected all of these. You can see what they look like. Not very interesting. But now I can update contributors, set the name equal to question mark, where ID is equal to question mark, and which now takes LE in out2 and executes this kind of cursor over here. And what is it doing? It's taking alt2 and an element over here. So let's look at alt2 is just the question mark, and then it's interpolating everything which is there in out2. So you notice what I did over here, just to give you an idea. In fact, I did all of it in SQL. Just go up and see. I said select ID, last name, first name from contributors. Once I got that, I took the second thing, the last name, added a comma, put a space after the comma, then put the first name, and then give the ID in there. And that's it. That's all I did. And now I was able to put it back in. So you see what I'm doing over here? I'm combining Python and I'm combining SQL in some kind of reasonable fashion, to update this database. And so that's your general paradigm in which you'll be updating either a database or a data frame. There's no drop column in SQLite. You'll find you can do aggregations. Select star max amount as max amount from contributors. You can do the same things in pandas. Let's see, how do you do it in pandas? Just get the max, amount at max, and then select that row in which the maximum is reached. And this is Linda Buckle, who we saw earlier. And then again, so on and so forth. You can do all of these kind of selects, and you can combine the selects with these aggregates, which we were talking about, who made the maximum contribution and all of these kind of things. Then you can do group aggregations. In pandas, it's group by. So I'm saying group by state. And this is I think this is the point that somebody said, okay, let's get the sum of the amounts in all states. There you go. Group by state.sum. That's how you do it in pandas. And if you want to do it in SQL, select state, sum of amount from contributors group by state. Very, very similar syntax, very similar verb over there. And there you get the sums for these various states. Now, at this point, you'll be like, why do they have negatives over there? We have not cleaned the data over here. So that would be something you would have to do. So there's deletions in how to do deletions over here. And so I'm not going to actually cover these. The one thing which is different in databases, which is actually kind of useful, is to index databases. It makes inserting and updating a little bit slower. but it makes the selections much faster. And especially when you get to extremely large sizes, you do want to do that in databases. So, but the last thing I wanted to talk about is this idea of joining. So I want you to look at this particular command. It says over here, take the candidates data frame and the contributors data frame and merge it with the candidates data frame. The left, i.e., from the contributors table, I want to use candidate ID. Right, which is the candidates table, I just want to use the ID because that was the key, right, between the two tables, and I want to merge it based on those. And then I'm going to choose the columns I want. And you'll see how it does it. It calls the thing on the left X, and it calls a thing on the right Y. And you'll see over here that it's merged based on candidate ID, and it's basically telling me that Stephen Agee contributed to Huckabee, and Charles Aiken contributed to Huckey, and Merrill Abishaw's contributed to McCain, and stuff like that, which is precisely what I want to be able to do, right? This is what I actually wanted to see in the first place. And so this is the way you do it. It's really quite simple. And there are other kinds of joins, which I will not go into, and you can look at it in explicit detail. But this is probably a good point to get rid of the notebook and just finish off the last 2-3 slides I have over here and then take questions. So yeah, we're at the 1.5 mark. So this is probably a good point to stop. So I'll just give you an idea for what remains in this sort of like data science process over here. So what we talked about right now was this grammar of data. Well, what remains? Clearly, we got to model the data, right? And this is the part of the modeling that we actually do go into. First at the end of DS1, and then in DS2. At the end of DS1, we do a little bit of neural network modeling. And then in DS2, we do the trees. And then, so there are two main methods used to model tabular data, trees and neural networks. Trees, we start with decision trees, which are basically saying that, okay, let's make splits in the data based upon the values. So, okay, you contributed more than 4,000 or less than 4,000. Your zip code is this, or your zip code is that. You know, for categorical variables, it's basically also done a split just based on the variables themselves. So it's Republican, Democrat. Are you Republican? Are you Democrat? So it's kind of like this tree-based structure which you create to do this modeling. Now it turns out that these trees are actually extremely fragile. So they're not actually terribly good models. So what you do is you combine multiple trees which have been created by cutting up the data in different fashions. And this is called a random forest. You average all these trees together. And random forests are incredibly powerful models. There is still a third way to do it, which is to use actually really bad tree models and then sequentially fit them. So first do the tree and see what got left over, and then fit that, and then fit that, and then fit that, and then fit that. This is called gradient boosting. Again, we do this in DS2. It's also a very good model. And these tree-based models are actually, even today, the best models for tabular data. Not everything is neural networks good at this particular moment. However, neural networks are actually starting to become competitive. And they're really simple neural networks which are used for these, which are based on simple tabular models and somewhat based on attention-based tabular models. Attention is a concept you would learn in AI 3 for language-based models. And the funny part about these neural network models is that you actually take these categorical data and you convert them into real value data. And this is called an embedding. Some of you may have heard of these embeddings called word2vec or glove, which are used in natural language models. And a lot of natural language models today basically train their own embedding. So it's actually a really, really smart but cool idea in which you convert everything that's categorical into stuff that's continuous, and therefore are able to sort of like surface correlations in it. And these models are actually becoming competitive with neural networks. With the tree-based models. And in a very strange twist of fate, they've actually improved the tree-based models. So what people now do is that they actually train the neural network models. They get the embeddings out, and then they use these embeddings as input features, create new tables with these embeddings only, and use those as input features into tree-based models, and the tree models do better. Why is this the case? How is this happening? we don't completely understand. This stuff has only started happening since about 2016. This is very new kind of modeling techniques for tabular data. And tabular data has been around since relational databases. So that's almost like 60 years now. 60? No, I would say maybe about 50 years. So it's kind of wild that we're still actually doing research in this field. And something that looks like a very staid, very old kind of field, looks like there may be performance to be eked out. So that's the next thing that we do in our course. We teach you how to model tabular data. And then finally, you have to interrogate your model to see why it's predicting what it's predicting. So you got to do all of that kind of stuff. You have to do multiple models and see which one is the best, and you got to interpret it. And I think you'll kind of recognize that when you're doing these multiple models, changing the parameters of these models, maybe changing how deep your trees are and all of these kind of things, you need tables again. And this time, these tables have to compare the performance of these models. So there are different kinds of tables, but you need tabular data again to be able to compare this. And you will again manipulate this tabular data either in something like SQL or something in Pandas, depending upon what your company likes to do. Now, after having done that, you're still not done, actually. There's something called decision theory, which you need to know. And the idea behind decision theory is, okay, I've got a model. It's making some predictions. This contributor is going to give money to this candidate, and this contributor is going to give money to Republicans. This one's going to give money to Democrats, for example, for a classification problem. Another example is, okay, I've got all these attributes of a customer, what things they bought from me, their behavior, their buying behavior. Okay, am I going to lose this customer? So this is a thing, a company like Jio or Airtel wants to do. Is this consumer going to go from Airtel to Jio? Let me try and predict it. And if I predict he's going to go from Airtel to Jio, let me give him an incentive. Let me reduce his monthly price for the next year or so that he stays with Airtel rather than going to Jio. So these are the kind of predictions you want to make. But the point about making these predictions is you really don't want to necessarily answer the question, is that customer going to bolt from Airtel to Jio? What you really want to answer is, what do I need to do to optimize the cost of retaining these customers or the entire set of customers who are likely to go from Airtel to Jio? Because some customers are more likely, their probability of going is higher. Some customers are less likely, their probability of going is lower. So I want to be able to optimize this, right? Based upon these probabilities. I mean, perhaps I want to target the most likely ones to leave and give them bigger discounts, and the less likely ones to leave, give them smaller discounts. And perhaps I want to do this in the context of a budget, right? Because these budgets are actually kind of important things to think about. Your boss may not give you all the budget you want. So this is really what your boss is paying you the big bucks to do. And so this is what you ought to be able to do as a data scientist. It's not enough to just run a model. You ought to be able to make predictions which are actually germane to the business line from that model. And so then that's the next thing that's important to learn. And whether you learn it with us or whether you learn it to somewhere else, make sure that you hit all of these in your education to become a data scientist. You must grapple with the uncertainty of your predictions, right? Because all predictions have uncertainties. And if your predictions are not very robust and the uncertainty is extremely high because they're not very robust, you have an overfit model and you have stuff like that, then you won't do so well. And a slight change of assumptions, which always happens in real life business situations, will make your model not so good. So you must grapple with the uncertainty of it and be able to communicate that uncertainty to your stakeholders in your problem. So all of these aspects, modeling and after, are covered in DS1 and DS2 in these courses, and actually in all our courses, because we try and put these ideas of metrics to use and so on and so forth in all our courses. So even AI1 had a section on it. So I guess I would like to end by saying I've kind of laid out over here this kind of notion that manipulating tabular data in any system, whether it's in R or whether it's in Python Pandas or in SQL, is similar. So learn the basic ideas of this manipulation. And then once you learn these basic ideas, learn them concretely in one of these systems or two of these systems, like Pandas and Pandas and SQL, or if you're an R person, in dplyr and SQL or something of that sort, right, in the tidyverse. So just learn it in one of these scenarios. And once you're there, you can do it in any other thing. You'll pick it up. That's not going to be a problem. So that's my first point, right? This kind of grammar of data idea for the talk today. The second point I've tried to make over here is I've illustrated through the courses we have in Univ.AI the things you really need to be able to do to be a data scientist. And these are these kind of slides, and I will share these slides with you afterwards. But what are you going to do after modeling, right? Well, how do you model tabular data? So these may be the most important side. What's this grammar of data that we're talking about, right? You can leave out all the concrete things we did. What's this rubric for doing this kind of data analysis? What's this data science process? Figure out something at each point of this data science process and how you're going to learn it. We have laid out our data science course so that each and every part of this process is covered. You can learn it by learning it with us, or you can learn it by learning it with somebody else, but make sure you cover all of these. So let me end on that note.